This video will go through how to do each of these 4 examples since we didn't get through all of them in class today. And it'll be a great review for the 3 or 4 questions on our exam, on our first exam. So what this first question does is ask us to tell the story. And so I want you to notice the axes on the graph and how we can begin to see how this graph tells a story. So in this story, we can see that I'm going to annotate in purple, and then I'll try to color coordinate everything. So here, right, we can see it has a starting point. And we're looking at position versus time. So as our time is, right, our time along our x-axis is moving, we can see our position in some cases, right, the y value is changing. And so what I want us to notice is, erase all the annotations, is that we can start describing this as a story. And so we can see, I'll change the color to that, right? So the position of, maybe we call it a person, right? This person, maybe it's a turtle leaving the water. We'll probably have some more context so we know exactly what's going on, is 1/2, or if you want to write it as 0.5 meters from, and then this, the starting point. And I guess I want to elaborate here, is that this is the person starting point, where this is maybe the start line, maybe if it's a race or something like that, or maybe that was the water, right, when we had that distance from the water. Or if this is like the matching graphs, this could be where the motion sensor is. So the person starts here at, right, 1/2 meter from 0. And then we can look at what's happening here, right? It's this constant function. We labeled that, and I'll make this, right? We can, is y equals 1/2. We're going to label that line, right? And then, so what's happening is time is moving, but their position is not changing. So they stay still until, right? It would help if I could make a 5 seconds. So they're just standing still from 0 seconds to 5 seconds. And then at 5 seconds, we can see that now we have this movement. So from 5 seconds, they start walking away from that. I'll just put it in quotation marks, right? That starting point at a constant speed. And we know this second part, this idea that they're walking at a constant speed, because this is a straight line. If their speed was changing, meaning their position was changing faster over time, right? Then that's where you can get these different curved lines. But if their position is not changing, or sorry, if their position is changing kind of at this steady, right, this what you might call like a steady rate, then that's where we get a straight line, right? This constant speed, meaning a constant slope. And we'll put in what that speed is. Well, I guess actually we could read that now from the graph, right? Our speed is going to be the change in position So this is going to be 1 meter over the change in time. And this is 4 seconds. So they're walking, their constant speed is 1 meter every 4 seconds, or right, 1/4 of a meter per second is kind of how you can see that as a speed, as a rate. And now we're going to look at, and then they walk until 11 seconds, right? All the way until here is where this part ends. And now at 11 seconds, we'll change to our green. What happens here? Right? They're just right? There's no slope again. Meaning their position is not changing, but the time is still changing, right? Time is still moving, but their position isn't changing. So then, oops, right, at 11 seconds, they stop and stand still until 15 seconds. And then, you know, their position is 2 meters from that starting line or start. And so what I want us to see is that if we're using this interval notation, we can talk about these different intervals. So I'm going to put us back to, I'll put us in black. So we are constant on the intervals from, and maybe this, we'll see. We're constant from 0 to 5, right? Our red line, and then again from 11 to 15. And so you can write that as an and sign, or you can see that as the U for the union. So the interval that we're constant is these. And I want you to notice that both of these are parentheses, meaning we're not including the endpoints. Whenever you're talking about intervals of increasing or decreasing, or even being constant, then that's where we don't include the endpoints. Only with domain and range would we include the endpoints. Then we can talk about where we're increasing and then where we are decreasing, and then we'll do the equation. So we're increasing in the blue, right? That's the only part where we're actually moving up, or that we have that positive slope. So we're increasing from 5 seconds to 11 seconds. And then there's no interval for decreasing. We're not decreasing at all. There's no negative slope. Actually, make this a little bit bigger. And then, so we can look at this function. And so I think that's what, right? Be sure to, now we're going to do domain and range next. But it says write the story using interval or set notation. So we can do that using our interval notation here. Constant, meaning they are, right, standing still on those two intervals. Increasing means moving away, or their position is increasing in between there, and their position is never decreasing. They're never walking back towards that starting line. So now we can see that this graph is cut up into these 3 different lines. And so the first line we labeled, like, this is the line y equals 1/2 x. Sorry, not 1/2 x, just y equals 1/2. There's no slope. So it's the same as y equals 0x plus 1/2, right? The no slope means that 0 times x would be 0. So we don't need to even write it at that. We can just write it as the y-intercept. Y equals 1/2. And that's the same thing that's happening there with the green, y equals 2. So we can write this function, this piecewise function, as these pieces. So what this is saying is y equals 1/2 when x is in between 0 and 5. Then we can see the green as y equals 2 when x is in between 11 and 15. And now with the less than or equal to, we're not sure exactly if these endpoints are included here with the green or included here with the red or with the blue. So I'm going to say that they're with the red here and then with the green here and not with the blue. So our blue interval is going to be this interval right between x equals 5 to x equals 11. So this is where we get those numbers, right? And that inequality. And then, so now we want to think about, okay, well, we had this slope of 1 meter every 4 seconds. So we can write that as 1/4 x, but now we got to figure out what is my y-intercept, right? Because I'm either going to do plus or minus b here. And so we figured out in class, it was -3/4. But I can show you the algebra on the side. I just want to make some room for it. So we know the equation of a line is y equals mx plus b, or one way we can write the equation of a line. And this is our slope intercept form. Another way we can write it is our point slope form. And so what we saw in the last graph, and I'm sorry, it's going to take a lot to go back and forth, is that we had a slope of 1/2. Maybe I'll do another color. Our slope was 1/4, but we are looking for, right? We want to find b. We didn't know what our y-intercept was. However, what we did have was we could read some points from the graph. We had 5, 1/2. We had a 7, 1. And so these are just points from the graph that you could read right from the graph. And then what we can do now is with a slope and a point, we can use our point slope form. And so algebraically, what that looks like is y minus, and then our y1 is our, I'm going to use this point so we can use the whole numbers. So this would be our x1, y1. And that equals our slope. And then now our point, our x value is 7. So now we can, once you plug it all in, we can just simplify it. So that way we can now take this point slope form and put it into, right, our slope intercept form, our y equals mx plus b. And we do that by simplifying this equation. So y equals, we multiply in the 1/4 times x to be 1/4 x, multiply the 1/4 times the 7. Now we can just simplify that. 1/4 x minus 7/4. 1/4 times 7 is just 7/4. Now we can add 1 to both sides, add 1 to both sides, y equals 1/4 x. And this would be, so you have a minus 7/4 plus 1, and 1 I'm going to rewrite as 4/4 because that's the same thing, right? 1 and 4/4 mean the same thing. I wanted to make that common denominator so that way I can simplify that, and I get y equals 1/4 x minus 3/4, right? -7/4 plus 4/4. -7 plus 4 is -3, and then fourths, right? The 4 is just my denominator. So that's one of the advantages of point slope form, is that you can, when you have a point, you have a slope, now you can find y equals mx plus b. Another way to do that is using our slope intercept form, but again, now we want to, right, we're going to find b. So we can literally write y equals, and I'll try to color code it again, 1/4 x plus, and then now we're looking for b. We don't know what that is, but to find b, we can again use one of our points and plug them in for our x and our y. So I can take the 1 and the 7 and plug them in for my x and y. And now I can simplify to find b. So I can see I have 1 equals, again, 1/4 times 7 is 7/4 plus b. Now I want to take away 7/4 from both sides. And now I get 1 minus 7/4 equals b, or 4/4 minus 7/4 equals b, which gives me that negative 3/4. And so now I have my m and I have my b. And so I can rewrite my equation as y equals 1/4 x minus 3/4. And so I want you to see, right? You see them either way, it's the same, you get to the same solution, the same equation. So there's just more than one way. You can use the different tools to get you there. So now we just explained how we got the equation here, y equals 1/4 x plus b. And if you're wondering, right here, you can see this point as 5, 1/2. And I'll label these, right? This is going to be 1 here, 1.5. So that's why this y value is 1/2. Or we can see the other point I found was just, 6, 7. This was 7, 1. And so you could have used any point. We could have used 9, 1.5 too. Any of these points, or even this last point is 11, 2, and got the same thing. So the last thing for this that we haven't yet talked about is this idea of domain and range. And so what we want to just talk about for the domain and range is, right, what are all of the numbers that are allowed in as our domain, and what are all the numbers that come out? And so you can write this in interval or set notation. For domain, we start at 0 and we end at 15. Right, that's my interval notation. I'm going to move this down actually a little bit. Or we could say, right, the domain is the set of all x such that 0 is less than or equal to x is less than or equal to 15. For the range, we could write, we start at positive 1/2 and we end at, well, not at 1, but at 2, right? This is our range. We start there, we go from there to there. Or we can say the set of all y such that 1/2 is less than or equal to y is less than or equal to 2. And so that's just practice of reading the across for the domain from, right, the starting point to the ending point is our domain. And then our range is all of the y's that come out from top to bottom. So the domain you look across, the range you look up and down. And either your set notation or your interval notation, whichever notation way you like better, works for me.